Okay. I'm going to put it in full screen mode now. Right. So once again, thank you for joining us today. Today's session promises to be hands-on. I've seen some of the feedback provided by the people. Yes, I understand that yesterday's session was, somebody said, overwhelming for people who are just starting to learn R, newbies, like the person said. I do understand that, but the good news is that today's session is practically going to build on what we learned yesterday. So it's more or less like going to consolidate what you already know. I hope you did have the time to go through the slides and probably watch the videos so that we can all be on the same page. But again, the good news is today's session is also being recorded. So you also get to watch this over again. Hopefully, our facilitator will make this recorded session available as soon as we finish this session today. So a quick reminder, like I said yesterday, I'm using my internet. Hopefully the internet will hold like it did yesterday. But in case I have issues with challenges, I have a backup internet subscription. I'll just quickly switch and then we'll be fine. All right. So let's just do a quick recap of what we learned yesterday. So we talked about a bit about statistics. We reminded ourselves about what rows are, what columns are, what variables are, and the type of variables we commonly work with: continuous variables, discrete variables, categorical variables. Then we talked about the building blocks of R, that basically we call them vectors. And R has 4 common vectors. We'll call these vectors double, which is more or less like a synonym for our continuous variables. We'll call the second one integer, which is more or less similar to our discrete variables. We'll call the third one character, like more or less like text, but we did clarify yesterday that R will convert, I will assume that anything that is in quotes is a character, okay? Now we talked about the 4th common one, which said is the logical variable, which is a Boolean variable, dichotomous true or false. Okay, but we said there are also what we call the augmented variables, and we'll give a few examples. Yesterday we said factors are one of them. Factor is synonymous to categorical variables. We talked about dates, date time, and then we talked about duration, right? So beyond that, we said most of what you will do in R, how you will interact with R will be using functions. And functions, all functions in R belong to a particular package. When you install R, I believe all of us have had the opportunity to do so. A few functions come pre-installed with R. There are most of the functions you will be needing, you will have to install them in additional packages. And the beauty of those additional packages is they greatly extend the functionality that R provides. And R being free and open source, anybody can contribute packages to R development as long as it goes through the standard validation CRAN provides and meets all the necessary standards. Then the person is free to contribute the codes. Right. We also talked about how you can manage a workspace, and we agreed that as much as possible, use R project to manage a workspace. And we did remind ourselves how to set up R projects, right, yesterday. We also talked about assigning names in R that are basically 2 common schools of thought. We have the ones that says, oh, use snake case. We have the other one that says, use camel case. But I did mention yesterday that my preference is for snake case, right? Then we talked about the arithmetic operators, and we talked about a few things that you should pay attention to. One of them is that when you are doing a test of equality sign, you should use double equal sign, equal, and not just one equal sign. Okay, and when you want to do not equal, is an exclamation mark followed by an equal sign. Right, these are some of the things we covered yesterday. We'll have the opportunity again to consolidate on all of them today. Today's session is not really going to be as overwhelming as yesterday's. So I'll try and take my time as much as possible, and I'm hopeful that everyone will be able to follow us. All right. So what are we going to be learning today? Yes, we'll be following this outline. We're going to again be managing our project directory. We did some of that yesterday. We're going to be advancing that. And then we're going to be importing data from the web. Dr. Benga already mentioned that the demo, the simulated data that I created is actually hosted on the web. A few of us might have had it when we did download the zip file, but for the benefit of those who didn't, and also for a particular reason that I'm going to bring to our attention in a bit, we're going to import it again from the web, and we're going to also download from the computer, our computer. We're going to be using 3 different file types, at least file extensions, so you're quite familiar. I can work with most extensions, many of the extensions of files that you know, but for this particular demonstration, we'll be using the CSV format, we'll be using the Excel, and we'll be using your standard text file, all right? I'm hoping that at the minimum, we have Excel's or an application that I can open XLSX file installed on our computer. We'll be doing the data cleaning today. We'll be looking at some summary statistics and we'll be saving our output. Inferencing and things like that is probably not for this preliminary class, so we'll be reserving that for some advanced session. All right, so I'm back. Apologies for that short break. Right, so basically, this is the outline we'll be following. Drop messages in the chat box. I'll try to attend to them as soon as I can, and we'll take most of the questions at the end of the session. All right, so just a quick summary of our data again. We have a data that's 10 columns and 10,000 rows. Right, it's a simulated data, but I believe it works for everyone. It's something we can collect during standard research or in the public health sector when we administer form or things like that. So these are the descriptions of the 10 columns, and I want us to pay attention to this. The first column is the ID, and the second is the date. The third column tells us the current age in years, the respondent. The fourth column tells us the biological sex of the respondent. So imagine you're doing an analysis and somebody has provided this guidance for you that this is the data I've collected. I'll allow you to help me analyze. And it's telling us that, okay, I did 10,000 respondents, but they're in 6 states of Nigeria. And as mentioned, the states, Rivers State, FCT, Lagos, Sokoto, Abia, and Kaduna. I think we have a few people joining from some of these states. And told us, okay, for married, I collected it as a yes or no. I didn't ask them whether, I asked them, are you married? Yes or no, not marital status, right? So did also collect weight in kilograms, height in centimeters, collected blood pressure. Again, for the sake of those who might not be in the health sector, blood pressure is but I'm hopeful that at one time or the other, you would have had your blood pressure measured in the past, so you should be quite familiar with it. There's 2 values, one at the top and one at the bottom. Okay, the top is the numerator, it is systolic blood pressure, and the bottom is the diastolic blood pressure. All right. And then the person decided that, okay, whoever it is said I should also collect BMI from the field. So I was busy dividing the weight by the square of the height in meters. So I tried to do that, and I also put it in my data. So it has 10 columns, all right? Okay. So we're quite familiar with our data, and then we'll see how our data is. But right now, we want to talk about your project directory. Right. So in addition to the things we talked about yesterday, I'll just quickly also like to mention to us that generally, it's important to be organized when you are doing your analysis. You want to create different folders in your project directory. Generally, it's encouraged that you create one where you put your scripts. Traditionally, we call that directory, that folder, we call it R. It's also encouraged that your input data, you should have it in another folder. I like to name that one data. And the outputs from your analysis, you probably also want to keep those ones in another folder. We are going to be having images. For example, you might also want to keep those ones in another folder. So we'll go and try ahead. We'll try and try our hands on this. And because we are using R, honestly, as much as possible, we want to avoid point and click. We want to do all these things using codes because that's the whole essence of doing a reproducible research anyway. Right. So I'm going to put the link to the zip folder in the chat box again now for the sake of those who might not have it. So I'm going to go ahead and stop sharing this. Sorry. So I'm going to go ahead and just get the link to our folder from yesterday. Then I'll drop it in the chat box for those who might not have it yet. Okay. So this is the link. No, not this. Apologies. Just okay. I hope we have it. I'm having trouble getting it right now, and I wouldn't want to take so much of our time. So I hope we all already have it. So what I'm going to go ahead and do right now is I'm going to stop sharing this, and then I'm going to share my folder that I did download. Okay, this is the folder I downloaded called intro_to_r_demo-master. I believe this is what we probably all have downloaded online. So I'm going to click into it and then click into it again. And then when I see this in this .r approach file, I'm going to double click it, which is going to open up in RStudio. All right. So I hope that you are following with me as I do this. I'm going to go ahead and share my RStudio environment now. Okay. So this is the RStudio environment. This shouldn't be open because you probably won't have it open. Most of us will probably have it set up like this. All right. So what we agreed to do yesterday, which I believe you must have done, is to run all these codes to install all the necessary packages on your computer. So I'm going to assume that we have all done this, so we're not going to do this again. All right. So the instruction now is that going back to this place, we already have a folder called R. But we also now want to create two more folders, one for our data that we're going to be using, and we're going to create one more for our output where we're going to be saving our output. All right. So to create folders, we can just go, for example, into this, our folder on our local computer. Let me share that. This place. And I can do my standard create folder, and I'll name one data. and then I'll create another folder and I'll call it output. This works fine. But again, I generally don't want to encourage this. I would love to teach us best practices from the beginning. This is really not reproducible. You can create your folder directly from your R environment. So you really shouldn't need to come and do it manually here. All right, so I'm going to delete this output, and then I'm going to delete this data. And we're going to go back to RStudio and see how we create it directly from RStudio. All right? So to do that directly from RStudio, I'm going to open a script. We said if you want to open a script, you can just do this plus sign here and click on open our script. I'll show us a better way to also do that without having to point and click in a bit, right? So there is a package called DevTools. Like we said yesterday, most of the functions you will be using are in packages. Over time, you will get familiar with these packages and you will know their names and the rest of them. It's just something that will have to come with time and practice. So I'm going to run DevTools. And right now, the functions in the DevTools package are available for me to use. So there is a function called use directory. All right. So what the use directory does is that it creates a folder for you. Okay, so it looks into that folder where you have the .r approach and takes that as the home directory, the home folder where your project resides. And from that, it references every other folder, all right? So I would say inside this place, create a folder called data, just like we did before, okay? So you pay attention to the window on the bottom right. You will see that as soon as I execute this code, we will have a folder called data in the bottom right, okay? Boom, we have it, the last entry there. Okay, so we want to create a second one. We said we'll call it output. Output. Yes, we have output too. Excellent. All right, this is good. Lovely. So the next thing we want to do now, I think we've set up. So let's go back to our slide presentation and see more guidance from there. Okay. Okay, so I'm going to do that in a bit, but for the sake of our time, and the good thing again, like we said, this video is really going to be recorded. So we'll try and make it available as soon as possible. But for this particular step, I'm going to go ahead of it. I mean, I will go ahead and take it again for the sake of those who might have missed it, right? But I'll do that in a bit. Okay, so we have organized our folders, all right? Then the next thing is, basically we encourage people, when you want to start your analysis, take your time, probably get a pen and a paper and write through the steps. Think about what you're going to be needing, all right? Or are you going to be needing just a single script to do your analysis, or will you be using multiple scripts? Now, you probably might use multiple scripts if you want to create segments, you want to divide. Maybe it's a very long analysis, probably running into several thousands of codes, and you're thinking about, okay, let me just keep them separate. Maybe I'll call one for importing, I'll call another one for cleaning, another one for visualization, another one for modeling, or things like that. So you want to think through all these things. And if you're going to be using one single script, like we're going to be using, it's also very good to partition your script, all right? So that you understand, okay, this section is for this. Generally, I try to follow these steps that I have mentioned here. I tell myself, okay, this particular session, I'm just loading packages. This other one, I'm importing my file. This one, I'm doing the cleaning. I'm doing the exploration. I'm just trying to understand my data. Now I'm plotting charts. Now I'm trying to save. So generally, I try to organize my codes like this. And we're going to be using this particular format to keep our code environment very simple and straightforward. I also like to talk to myself, not just because I don't understand what I'm doing, but because one, I might leave this analysis and come back to it after a few months or a few days or a few weeks. I might get confused. Why did I even do this? So I talk to myself. There is room to write text, to provide comment. The second reason why you want to provide comments is that sometimes you share your codes with people, and it's good to let them understand exactly what you're doing, all right? And we also like to keep things simple. Again, like I said earlier, when you open your R afresh, anytime you close RStudio and you reopen it, only 6 packages are made available. Functions in 6 packages are made available to you by default. These packages are the ones on the right. Irrespective of how many thousands packages you might have installed on your computer, to be able to access function in all these other packages, you must load those packages first, all right? You must load those packages first. Sometimes this is where people get it confused. They feel like, I already have the package in my system. Can't I just call the functions in the package? You can't. Because again, there are several thousand packages. A few people have several thousand. For example, I have 1,600 plus packages. I think it just got to 1,800 over the weekend on my computer. And I can't be working with all of them at the same time. If I try to, it's going to eat a lot of my memory, my RAM. And R tries to be as efficient as possible with memory. So R only works with what is needed at a particular time. If you don't need those packages, R will not load them into memory, because the moment they are loaded into memory, they affect your overall system performance, all right? So you only want to use the minimum that you require. So like I said again, you got to that paper, think about those packages you will be needing for each analysis. Generally advised, load them at the beginning of your script, all right? Even down the line, if you remember that, oh, I might need 1 or 2 other additional packages and I'm yet to install them, you can just come back and quickly say, oh, okay, go back to the beginning of your script and just add that package there. All right. So the next thing is we're going to be installing our file. We have it on the internet, so we download a local copy. And after we have downloaded the local copy to our computer, we're going to now import it into R. Now, while I was preparing for this particular class, I did notice that I have a CSV file. But then I realized that, like Excel has done to me countless of times in the past, Excel does something to CSV files. It messes up with it. And I'd like to show us how Excel messes up with your file and how why one of the reasons why you might have to be careful with Excel. So so because of that, we're also going to import Excel, and we're also going to import text file. I'll show us how we will get this ones, even though we will be downloading just the CSV file. And what we will do is, immediately after we've imported our file, we'll have to study it. Recall the concept of tidy data. Is it tidy? We want to ask ourselves that question. Recall the concept of variable names. We said, as much as possible, we use snake case. Our variable names in snake case, we also want to look at that, all right? And then we will take it up from there by doing this few analysis. But before we do further analysis, and I apologize that this is not really so clear, especially the picture is not really so clear. I want to introduce us to 3 more functions. Okay? The first function is the $sign. And what the $sign practically does to us is that when you have a table, a folder, rectangular with columns and rows, let's assume that you have assigned it my data, for example. Or let's call it demo data, like the one we're going to use. And we said our demo data has a column called age. If I specifically want to get only the age column, and I want to see all those age in our demo data, I can just write demo data That's demo underscore data $age. So it's on the left of the dollar sign is the name of the data you want to access. On the right of the dollar sign is the name of the column. All right? So that is the dollar function. Then the unique function tells us, oh, look through this particular column and tell me only the unique entries. Recall again, we said we have sex, which can be male, female. So ordinarily, we'll be expecting only 2 unique entries in that particular column. So we're going to use the unique sign to check, do we actually have just 2 unique entries or we have more? And this last particular one of the best inventions of that was recently invented, I think just maybe about 5 years ago or less, is the percent greater than percent. Yesterday, we talked about percent in percent, but today we're talking about percent greater than percent. Again, yesterday we said the percent in percent, we pronounce it contains, but the percent greater than percent, we pronounce it then. I'm using the picture on the right to show us how this works. Again, I apologize, it's really not clear, but I'm going to just read it to us. Imagine that I want to document the steps it takes me to go to work in the morning. So my name is Stephen. Let's say the process of waking up is a function. And after I wake up, I have to go to the bedroom and have my bath. All right? And then I have to now get dressed up before I can go to work. On this particular day, I decide I'm going to wear casual. So there is the option of what do I wear, clothes, and the shoe I put on. All right. And then I have to transport myself. Lastly, I have to transport myself to work. So let's assume this is like a code function. You're putting it together as a code. So the first thing is going to be wake underscore up Stephen. I'll have to save that and assign it a name. I'm calling it getting to work. So Stephen is awake now. So getting to work is equivalent to a Stephen that is awake. And then that Stephen that is awake has to have his bath. And I'm saving that as an intermediate called getting to work 2. So getting to work 2 is Stephen that is awake and has had his bath. And then that Stephen that is awake and has had his bath needs to dress up, wear casual, and put on slippers. I'm assigning it to getting to work 3. And then that Stephen that is awake, that has had his bath and dressed up, has to transport to work. All right? Recall that we said all these other options are called arguments. So the mode is that I use a car, and the type of car that I'm using is a personal. This really looks straightforward because I'm having to save so many things. Getting to work 1, getting to 2, 3, 4, just because I want to document the steps it takes me to go to work. Naturally, I can use the second format just by linking all of them together. But this is more or less like inside out. You have to read it from the middle. Wake up Stephen, which is now surrounded by bath, which is then surrounded by dress, and then finally surrounded by transport. Again, it looks complicated, difficult to read. If I'm really not familiar, in fact, most times it's easier to write, but more difficult to read. So the then function came up, and it's like, why can't you start with the object, then the steps that are necessary? So Stephen, then wake up, then have his bath, then dress, and all the argument that comes with the dress function, then transport. And we save it only once. Right, so that's the beauty of the then function. I'm going to be introducing us to it. I really love it because it makes our work a whole lot easy. And we'll see how it also brings meaning to writing code because it now becomes easy to read and understand exactly what our code is doing. All right. So I think we've really talked a lot. But one of the final things to just be talking about is that now, when we read our data, we'll see some of these things, and then we'll come back to answering this question. So I'm going to stop sharing this. Then I'm going to go back to this. Right. Okay, so I've created all these things. Sorry, not this. Right. So I've created all these things. Okay, so I'm going to just, no, sorry, I seem to have a lot of things open. All right, so we're back to this place. So we've created our output folder. We've also created our data folder. So the next thing is we need to get our file. I'm going to copy the link to the file. Even if you already have it before, please just replace this with what you had before. Okay. I'm going to copy it and put it in the chat box. Please don't use it yet. Just hold on with it. I'm going to tell us when to use it. All right. So the next thing is, I have decided that I want to use my R script, okay? And I want to call it demo analysis. So there is a function called use R. It creates an R script for you. I'm going to call it demo_analysis. All right? And I'm going to run this. What it does is that because the function is use_R, it knows that I'm trying to create an R script and it's going to save it directly into my R folder. As you can see right now, the only thing I have in my R folder is the package installation. But the moment I send this to the console, that's going to change. Then we can see the demo_analysis. And then it opens up also for us here. All right, so this is what we're going to be using for analysis. Again, we said we want to divide our script into a few sections. If you just hold on to Control, then Shift plus R, that's going to be on Windows. On Mac, I believe that should be Command plus Shift plus R. Okay? If you press that, it's going to bring a panel up asking you the section label. All right? So for this one, I'm going to say load libraries. That's the name of this section label. Okay? I'm going to create another one, just like we agreed, a few of them, importing data. I'm going to create another one, data cleaning. Again, the function is Control plus Shift plus R. If you're on Windows, Command plus Shift plus R on Mac. I'm going to create another one called data exploration. Okay. I'm going to create yet another one called my data visualization. And the last one called saving data. Okay, so we're getting organized. We've created all our sections. Then you realize that there is a little downward arrow in front of each of these places that makes it relatively easy for you to code each of these sections. So it becomes relatively easy to understand, especially when you begin to have long lines of code and you just want to deal with only one particular part of it at a time. All right? So I'm going to go ahead and load my libraries. I believe we already have the Pacman package installed. Recall yesterday we said the Pacman helps you to manage your packages. So I'm going to run this library Pacman. Okay, if you don't have Pacman installed, please, Pacman is one of the package installation here. It was one of those we installed when we ran this package installation script, right? So if you don't have it, just run the package installation script and you will get most of the packages that you need to get you started, all right? So a few of those other things, I'm just going to list them right now. There is a preload function from the Pacman I will use to load the additional packages. All right. The first one is there is a package called downloader. We will use this downloader to download our CSV file from the internet. And I'm going to put comments. When you want to put comments in R, you use the # or the hash, Shift3 to create your comment. Anything you write after Shift3 is seen as a comment. Okay. So I'll put this as to to download our file from the internet. So that's what the downloader will do for us. The next package we will also use. So I'm going to, pardon, after each package, please put a comma. All right. The next one is we're going to use the reader. Read R. We'll call it reader. It helps to read CSV files. All right. CSV text files. That's the .txt extension. All right. Reader is very good at doing that. The next one we're going to use is called the reel. All right. Reel is for importing and exporting. Sorry, I just want to keep this a little bit tidy. Okay. For importing and exporting files. Right. The next one we're going to work with is here. What the here package does for us, it manages our directories. Okay. Yes, I do, Michelle again. When we ran this package underscore installation script yesterday, we have installed the Pacman package. It was part of those things we did when we were setting up our RStudio. Yes. Right. So the next one I'm going to do is the janitor. The janitor helps us to format our data. Janitor is very good for formatting. Okay, so run is just up here. If you can see my cursor right now, run is just above my demo underscore script, but you must have opened the script before you can see run. All right. So the next one we're going to use is the dplyr. So dplyr is like a plier. It's for data manipulation, just like you use a plier to manipulate things. Data manipulation, data cleaning. Okay. The next one we're going to load the tidier. The tidier package, more or less like to tidy data. That's why it's called tidier. So we don't need to download the payload. We are not even downloading right now because we have downloaded all this. We've downloaded all these libraries yesterday. Like I said, even though we have downloaded those libraries, we still need to load anything apart from those initial 6 that are loaded by default. So Pacman is not loaded by default. And by running library Pacman, we are not downloading it. We are just loading it into memory that, okay, avail me the functions that are in this particular package. All right. Okay, so I think we are done for now. If we remember any other additional package, we can just always come back up here and include them. All right. So what I'm going to do is I'm going to now run, I'll put my cursor on line 5. I'm going to press run to run all these ones. The good news, like I said yesterday about the p_load function is that even if that any particular package we have put there right now is not on your computer, don't worry about it. Pload will first check if it is on your computer. If it is there, it will load it. If it is not, it's going to install it and then load. All right. So one more particular package we're going to install right now is called Lubridate. Lubridate is for working with dates. Working with dates. All right. So I hope this is beginning to make sense. All right. So we've loaded our packages. So now we think we're done. The next thing we want to do is we want to come to importing our file. But before we import our file, we need to make sure that we download it from the internet. All right. So we'll get the URL. That's the link to our file. I'm going to paste it. It's a bit long, so I'm going to have to expand it so we can all see. And we have put it in the chat box. This is the URL where our file is, right? So I'm going to assign it to URL. Don't forget that we said to get this greater than sign followed by hyphen, you can just press Alt plus minus on your computer, and it becomes very easy. Mr. Anu, I'll take the explanation about loading packages again. When you open up R or RStudio, you have just 6 packages made available to you. Okay? But if you need additional packages, so when you take your pen and paper, you will have to think about what packages will I need to use for this analysis that I want to do. And we have listed that we will need all these particular packages. So we're going to call the preload function, that's the p_load from the pacman like package to load all those packages for us. So you just call preload and then you list all the packages you want loaded, separate them by a comma. All these comments here are optional. That is for us to just give us an idea why we are loading these packages. And as you can see, we are not loading what we don't need. We need all these things. That's why we are loading them. All right. So that's it. Mr. Wahab Kayode is asking, do we run the liquidate package since we already pressed run before including it? Then if you have done that, just go ahead and run it again. So I'll put my cursor on line 5 and I'll run again. That's very important. All right, because that you have written something here does not mean that it has been executed. You have to get to the window on the left side, or on the left downward panel, and you must see it here before you can say that this has been executed. So this has been executed now. Lubricate has also been loaded. All right, so we're good. So again, we have the URL, all right? So the next thing is we want to call download. The download is a function from the downloader package. Recall that we said we are loading this downloader to help us download. Not surprisingly, the function you need to do that is called download. All right. So the first thing you want to tell download is, what do you want to download? We want to download the file that is in this URL, right? So we're going to download URL. Okay. And the next thing download asks us is, where do we want to put the downloaded file? Okay. So we're going to use the here package here. There's a function called here, and it's also in the here package. So don't worry too much about that. To tell download where to put our file. So here starts where this our project file is. Okay. Okay. Somebody is asking, how did we create demo_analysis.r? Okay, so that person is taking us back, but I'll just quickly do that. The first thing we did when we came here was to load a package called dev2, library dev2s. And the second thing is that we decided that our data, we're going to put it in a folder called data. So we called the use_directory function that created this data folder for us. So we just ran it. We put our cursor here and we did run. Then we did another one for output that created this output folder for us. Then the third one we did is that we said we need a script, an R script, and we call it demo_analysis. The function for that is called use_R. So we ran this use_R with demo_analysis in the bracket, and it put our R script inside our R folder. That's why we have this. And it opened it up for us up here. So that was how we got to this demo_analysis, the script. Okay. So we have our library pacman again loaded. We have the preload function, and we have listed all the packages that we need. We have our URL, of course, the link. We have assigned it a name. Again, unsurprisingly, we're calling it URL. And then we're calling it download function. We're saying download the file that is in this link, all right? And the here function to tell it where do we want to save it. So again, here starts from your home directory, which is where you have the .rproj, right? So here, from here, I want you to go to the folder called data, right? And I want to name my, when you go to the folder called data here, which is currently empty, I want you to call my file demo data.csv, all right? So it's going to go to this link, download a copy of our file, and it's going to put it in our data folder and call it demo_data. So I hope that's clear to everyone. But first, we need to start executing from here, okay? So we have the URL now, we've executed. If we look at our environment, our URL is there. It knows that it is HTTPS something, something, something. And then we're using our download function to download now. And it's downloading. And boom, if you look at the right, I have my data there. Okay? Now I'm going to open this up. I can open it up and say view file. And I want to show us something. You see, it's comma separated, so it's not surprising that we're seeing ID, comma date, because it's a comma separated file, that's CSV, all right? But look at the format of my dates. I'm going to highlight it for all of us. We can see it's the ISO 8601 that I talked about yesterday. 4 digits year, 2 digits month, and 2 digits dates. I want us to keep this in mind very well. All right? Okay. So we've downloaded our CSV file. This is good. And like I said before, I hope we have Excel opened on our computer. I mean, we have Excel installed on our systems. So what I want you to do is go to the folder itself. Okay, so I'm going to stop sharing this now. And I'm going to share the folder itself. Okay. And we can see that my data now, I have the demo_CSV that I've opened. I'll open it up in Excel. Okay. So I'm going to share that Excel with us now. So I'll stop sharing this again and share that Excel sheets. And I want to save it as Excel. So I come to File, Save As, Browse. I'm going to change the file type to Excel Workbook, and I'll click on Save. All right? But in addition to that, I also want to save it as a text file. So I'll come to Save As. Okay? And I'm going to save it as text, the one with ms.dos text, something like that. I'm going to save it too. Okay. I'm going to close this. You see, I really didn't touch my data. All I just did was save it as a text file and save it as Excel. Nothing else. All right? Okay. So if I come back to my data, you can see I have the demo_data.csv, demo_data.txt, and demo_data.xlxx. Good. So we've created a copy of our file as CSV, as text and as Excel. Excellent. So let's go back to our RStudio environment. Okay, somebody asking if I copy the functions in the chat so we can all run it. I can do that, but as much as possible, I would have loved so that you can also type yours and becomes that easy for you to practice. So I have already copied the URL. I hope every one of us will have it. I'm going to copy and paste the download folder, the download lines of code. Okay. We have our file downloaded. We are going to try and read these three files. Why do I have two copies of my text data? So, probably just a bit of mess up. All right. So we're going to see how we can import this CSV file. Then we're going to import this demo underscore data and then demo underscore the text file so that we see how to work with text, CSV or Excel, whichever one you have to work with at a particular time. All right. Now, here comes the real package. There is a function in the real package that is called import. I love it. It's just simple. Import, right? Generally, I advise if you are importing Excel or CSV, please just use the import function from real package. I will explain what it does in the backend in a bit. But for your Excel, for your CSV, please just use the import function, right? And it's already showing us all the arguments that the first thing it needs is the file, okay? So let's come here and say file path. That's the path to our file, this one that we want to read, okay? Or better still, file CSV. That will be the path to our CSV file. So again, it's going to be here function. From the here, we're going to the right, the data folder. Again, don't forget that here is this place where our project.rproj is. So from here, we enter into the data folder. And from the data folder, we have the name of our file, demo underscore data.csv. All right. As for our file CSV. Okay, so let's run it. Okay, so we want to import file CSV, right? What's the next argument that import needs? If you press tab, it's going to show you the other arguments, and you can just use your down button, okay? Right. So if I do, for now, I'll just do this. I will run this code. If you look at it here, we have our CSV file, right? That's simple. Import the path to our file, and we have it. Look at it, beautiful. But a few things are really not right now. Number one is we are having to scroll because this is printing a lot of things for us. It's printing 100, okay? There's a better way to print. Number two is that unlike what I showed us yesterday, where we could tell the type of variable for each column, this is not also showing us. So to do that, we're going to just add one more argument here called set class equals, I'm going to say table. Table is a type of, it's just a format for printing. And what it does is that it prints only the first 8 to 10 for you,